Hello guys. I am going to be talking to you about the Mass and Volume Lab and what we learned from it. I apologize if my voice is a little hoarse. So in front of me here, I have all the class data we collected from the lab. And as you know, if you were on a blue day, I went through and kind of removed some of the biggest mistakes in the data. I know it's not the world's greatest science, but I knew there were mistakes. And then even eighth period today, I actually went and removed your messed up data as well. So this is the cleaned up data. And we were going to use this data to identify our two unknown metals. There were two options here. One was you could actually graph all the data following my instructions. And when I was scrolling, you may have noticed that all of the data for metal B got moved over a column. This is something you need to do to graph two sets of data on a scatter plot for Google Sheets. Excel is easier, but sadly we don't have Excel. So I did this and I graphed all of our class data. I also graphed it using the template that I gave you guys, and we'll look at that in a moment. Excuse me. So I have our metal A and our metal B graphs, and I want you guys to remember that we learned from our comparing volume units lab that we're looking at our slope of a line, of course, and that the slope is rise over run, y over x. And in this case, the y is the mass and the x is the volume. Excuse me, sorry, I'm not feeling super well. So mass divided by volume is our slope. Now, in this case also, we do have a y-intercept for both of our lines. But just like on the comparing volume units lab, we can assume that y-intercept is due to error, because if something has zero mass, then it's also not going to take up any space. It will also have zero volume. So these very small y-intercepts are just due to experimental error, and we can focus on the slope. So the slope is the mass divided by the volume. Now, hopefully, mass divided by volume rings a bell from 8th grade in your head. If not, then hopefully you Googled it and said something like, what is mass divided by volume? And the internet would tell you that that is the property of density. So metals all have a distinctive density. Now, some of them are very similar in density, and as we'll find out in a moment, that might help us or kind of get in the way of us identifying the metals. But they do all have a density and a characteristic density. So I'm going to start with metal B because it's a bit easier to identify. If you recall, it was a light silver colored metal, and you can see the density is very low, 2.54. And since it's mass divided by volume, the units are mass units divided by volume units, which is grams per milliliter. Or since usually metals are in fact solids, we say grams per centimeter cubed. And I found this was honestly the first thing that showed up when I Googled table of densities. And if I look down the density, grams per centimeter cubed, for a bunch of metals, the only one that's close to the density that I had is aluminum. So the actual density of aluminum is 2.7, and my calculated density is 2.5, which is actually not too bad. So I can say with a reasonable degree of confidence, since there's no other metals close to that density, that metal B is likely aluminum. Now, metal A is harder because it has a density of 7.35. And when I look at my density of metals, up here at the top, I have a lot of metals that are a little higher than that, like iron. Iron, very important, 7.87. The one that I could find that was kind of close, chromium is kind of close, 7.19. But I know from experience that chromium is very shiny. Chrome-plated things are shiny, and this metal was dark gray, so I don't think it's that. And I keep going down. So the one that seemed like maybe it could be is indium, because I don't know what indium looks like, so I Googled it. And indium's also pretty shiny. So I thought, well, it was a dark gray metal, not a shiny silver metal. So then I decided to sort of think about what else I knew about the metal. It was dark gray. There were little bits of rust on it. It had sort of a metallic smell that I recognized, like that I recognized from previous experience. So it actually is iron, even though our actual calculated value of iron here is rather low. That's pretty common because our data is not great. That said, if you identified it as something else like indium or chromium, that is okay. and your numbers might have been a little bit different because you might have didn't graph the whole class data. The key thing is that you should have used your data to identify it. So you can use your data. You can also use your knowledge and Googling what it looks like. For example, I would never give you a very expensive metal like gold or platinum because I can't afford it. I wouldn't give you a radioactive metal because I don't want to kill you. So you can kind of narrow down your options that way as well. So even if you didn't say iron, as long as you based it on logic, you are good. Now for you guys, I actually gave you, let's look at the thing here first. I asked you if you didn't want to do the whole thing, you could use your template and choose just 5 data points. Now I purposefully chose 5 very good data points so that I would get, better numbers, since I happen to know, what their volume should be. The thing is that the volume, although it sort of should be these things, it's really not exactly. It's probably something like 1.55, not 1.5. But we did our best. And on here, I got slightly better numbers because I chose them better, but I still ended up with not perfect for iron. I got 8.1, and if you recall, it's 7.87 or 7.9. But it is a little bit closer to the actual density of iron. Now, since you chose your own 5 data points, you might have ended up spot on for iron, or if you chose data points that weren't quite as good, you might have ended up much further off and chosen another metal. Again, the main thing here is to think about the fact that density is mass over volume. The slope of the line is the density, and to use that and use your information from the internet to identify the metal. All right, hopefully that helps you understand our lab, and I will see you guys soon.